Okay, so this video is going to be the second of five in the day 12 of Unit 3 Algebra 2 video, right? And in it, we're just going to talk about the rational root theorem. I'm just going to do two quick examples here in the video. Super simple. So if you need to take a second to pause the screen and write down this definition here, feel free to do so. But I'm going to go ahead and just move on. Okay, so if we're going to use the rational root theorem, say on this function here, right, we're looking for x-intercepts, right? So if it's a function and we have it set equal to 0, we're obviously looking for x-intercepts. And I've already told you roots, solutions, x-intercepts, they're synonymous, right? So we know it's second degree, so we know there's going to be two possible solutions, right? Now, this is the rational root theorem. Okay, so rational numbers are expressible in the form P over Q, as the theorem states. P for us in this case is going to be -3. Q for us in this case is going to be 2. So that means our possible roots are going to come from the factors of -3 over the factors of +2. So the factors of -3 are going to be plus or minus 1 and plus or minus 3 over plus or minus 1 and plus or minus 2 when we're talking about our factors for Q, right? So first we look here. So plus or minus 1 over plus or minus 1, of course, that would just be plus or minus 1, right? Plus or minus 3 over plus or minus 1, well, that, of course, is just going to give me plus or minus 3. Okay, now we're looking here, plus or minus 1 over plus or minus 2. Well, that's just plus or minus 1 half. Okay, and last one, that's going to give us plus or minus 3 over 2. Okay, so all in all, that means we have 2, 4, 6, 8 possible rational factors, or rather rational roots, to this quadratic here. Okay, so if we go ahead and find the actual roots, right, so of 2x squared plus 9x minus 3, okay, we can go ahead and try to figure that out. So 2 times, so that is not going to require factoring. That's not going to work. So we're going to go ahead and just use the quadratic formula. So we're going to say negative b plus or minus the square root of b squared minus 4 times a times c, all of that over 2 times a. And these are going to be our actual roots that we're going to get from this. Okay, so -4 times 2, and I'll tell you what, just to save time, let's just check this in the calculator. So yeah, you can still see uh, it was saved from what I had previously. Okay, so I'm going to go ahead and go to calculate. I am going to hit Control Divide, and I've got, let's see, -9. We're just going to do the plus one first. Then I'm going to hit Control X squared. So 81 minus 4 times 2 times -3 over, and we know 2 times 2 is 4. Okay, so here we get 0.311 blah, blah, blah. So let's talk about why that is, right? So obviously this is an irrational number. So if I continue this out by hand, this would be -9 plus or minus the square root of. So this would be -8, positive 24, 105. So the square root of 105, all of that over 4. This is not a perfect square. Okay, so my determinant did not give me a perfect square. This means I'm going to have two irrational solutions. Okay, so this third thing, why did the rational root theorem not yield actual solutions, right? Because we already saw, according to the theorem, we're supposed to get these guys, right? Well, it didn't work out because we're going to get two irrational solutions. Okay, so let's do another example. Maybe this example will get us some better results. Okay, so this one's to the third power. We're not going to easily be able to figure this all out until we put a whole bunch of things together in the coming videos. Okay, so this time P is equal to 6, Q is equal to 1. So this time we're going to have plus or minus 1, plus or minus 3. No, let's do 2. It bothers me when I go out of order like that. Plus or minus 2, plus or minus 3, and plus or minus 6. All of that over, well, 1 only has plus or minus 1. Okay, so that means we're going to have 8 factors, because these are all going to just be over plus or minus 1. So that means our 8 factors are going to come from plus or minus 1, 8 possibilities rather, plus or minus 2, plus or minus 3, and plus or minus 6. Okay, so these are all the possible rational x-intercepts of the function. Okay, so in the coming videos, we'll see how this is going to apply. Okay, so that does it for this video. That's how you use the rational root theorem in a nutshell. That's what it's for. If you have any questions or concerns, come see me. Otherwise, shoot me an email. Goodbye.